Once again, good morning. To those who just came in, good morning and welcome to our class. I told you a while ago that our lesson today is very much related to our lesson yesterday. Now, our lesson today is about inverse. I'm sorry I texted you indirect, and even in the cola, I placed indirect. That should be inverse. Inverse variation. That's for lesson 3.2. And let's recite our memory verse for the day. Our memory verse is found in Matthew 19, verse 30. It says, "But many who are first will be last, and the last first." I think based on our memory verse today, you have an idea on what inverse variation is. The first will be the last, and the last will be the first. Let's talk about opposites. And today's MVCA boosters is about inverse variation in Bible verses. By the way, may I remind our modular students to please answer our MVCA boosters. By answering our MVCA boosters, you'll get extra points for each lesson. So even how simple your idea will be, please share it in our MVCA boosters. Our MVCA boosters talks about inverse variation in Bible verses. The Bible talks about inverse variation. In Philippians 4, verses 6 to 7, it says, "Do not be anxious about anything, but in everything by prayer and supplication with thanksgiving, let your requests be known to God, and the peace of God, which surpasses all understanding, will guard your hearts and your minds in Christ Jesus." Now, what is the inverse variation in this text? It reminds us that the more we pray, the less we become anxious. So more prayers, less anxiety. And your turn will be, you need to cite a Bible verse with an inverse variation. At the end of today's class, you'll be able to illustrate inverse variations, translate variation statements, and solve problems involving inverse variations. So let's start. Now here's the harvest story for our venture activity. Mario will soon harvest the corn in his field, and he was thinking about the possible factors that will affect the number of harvesting days. So the first thing he had in mind is the number of workers. How will the number of harvesting days be affected by the number of workers? We see the relationship of the two variables. More workers, it would mean less harvesting days. And how will the size of Mario's field affect the number of harvesting days? We say if the field is larger, then it will take more days to harvest the corn. Now, let's talk about inverse variation. Yesterday, we talked about direct variation. Remember, in direct variation, if one variable increases, the other variable also increases. For example, we have yesterday, the higher your quiz scores will be, then the higher your possible grade will also be. Or we say, fewer papers to be used, then the less paper pollution that we will have. This is for direct variation. Today, we'll be talking about inverse variation. In inverse variation, or we say when two variables are inversely proportional, it will illustrate that if y increases, then the other variable X decreases. So if Y increases, the other decreases. Or if Y decreases, then X increases.
So it's
Yes,
so it's an opposite effect.
Yes, the opposite. So if one variable increases, the other variable decreases. Remember our memory verse? The first will be last and the last will be first. Now, how do we write our equation of variation? There are two ways to write it. It can be y equals k over x, or k is equal to x times y, where k is a non-zero constant of variation. If you remember yesterday in our direct variation, our general formula is y equals kx. But in inverse, it will be y equals k over x. Now, what are some examples to illustrate inverse variations? Example, more workers, let's have the harvesting story. If you'll have more workers, then you'll have less number of harvesting days. Or if you have a higher temperature, then we'll have less number of hours to melt. Another, the willingness to buy a particular product is inversely as the price of the product. So we say, once we go to the market, if the product is expensive, then most likely you will not buy it. But if the product is cheap, then most likely we'll buy it. And the last, the faster the speed, the lesser the traveling time. So these are some examples of inverse variations. Now, how do we write them in English sentences? We say y varies inversely with x. Now, how do we write it? It's y is equal to k over x. That's inversely. Or another way to write it is y is inversely proportional to x. Let's have a drill first. Now, I'll place a number for a while. 1, 2, 3, and 4. Now, I'll assign people who will answer numbers 1, 2, 3, and 4. Let's have the first one. Let me check on the first one. I'd like to ask MJ. MJ will answer the first one. The second one, I want Vance to answer. Next, for number 3, is Ryan. Ryan around. The number 4 will have Taj. Okay. Ready, MJ? Where's MJ now? Okay, we'll start
he's
first.
using his laptop, man.
Okay, let's start first with Vance, number 2. Ready? I'll say the statement and you need to tell me, or in the chat box, you can type how to write the symbol, or you can unmute your microphone and give me the answer. Ready? Let's start with Vance. Number 2, air pressure P varies inversely as its altitude A. Now, Vance, how will you write it?
Is it P equals K over A?
Very good. P is equal to K over A. Very good, Vance. Next, how about Ryan? Number 3, Ryan. The altitude A of a parallelogram with a constant area varies inversely as its base. Ryan? Where is Ryan? Oh, Ryan. How about Ellie?
Ma'am. See, MJ, he's having trouble with his laptop now.
Oh, okay. So, Ryan is not around. Yes, AP, you raised your hand. Okay, AP, what's the answer for number 3?
Okay, the answer is A equals KB.
KB, like this?
Okay, K over B. So,
Very good. That will be A equals K over B. Ma'am, what happens to the constant area? This is our condition. So you could just disregard it as long as the condition is we have the same constant area. Next, how about number 4, Taj? The sum of money to be invested, I, varies inversely as the rate of the interest.
never mind, we might need to go to sir.
Wait, AP mute first. Where's Taj?
Here, ma'am.
Yes. Okay, what's the answer for number 4, Taj?
I am muted.
And I equals R, K over R.
Very good. How about the last one? And the first one, can we have Carmela? Can you answer number 1, Carmela? The number of hours to complete a certain job varies inversely as the number of people working it.
Ma'am, H is equals to K over P.
Very good. H is equal to K over P. Very good. I'll give you my virtual claps for giving the correct answer. Now we're ready to go to the next one. The next one is we will be solving for the constant of variation and the equation of variation given y equals 81 when x equals 3. Remember that our general formula is y equals k over x. So the first step will be we will substitute y, 81 to y, and 3 to x. So let's have that. 81 equals k over x, 3. Then we do cross multiplication. 81 times 3, so we have k equals 243. So this will be our constant of variation. But there's also another way to work to solve for the constant of variation. Remember that this one here. Remember that we can write it as y equals k over x, or k is equal to x times y. So if you want to solve for the constant of variation, we can just multiply x and y. So let's go back there. Ready? This one. So k is equal to x times y. So what's our x? That's 3. What's our y? That's 81. So we multiply 3 times 81 is 243. Now, what is the equation of variation? Let's write it. Based on this one, that will be y is equal to k, 243 over x. This is our answer for our equation of variation. Any questions? Let's try another one. Ready? Let's do the next one. The given is y equals 6 when x equals 18. Let's solve for our constant of variation. We have k equals x times y. Our x is 18, our y is 6. So K is equal to 108. Now, how do we write our equation of variation? We have y equals k over x. We substitute 108 to k. So we have y equals 108 over x. This is now our equation of variation. It's easy, right? Now, let's go to exercise number 3. This time, we will determine whether the table or the graph express an inverse variation. And if they do, let us solve for the constant of variation and the equation of variation. Now, how do we do it? Remember last time? The first step is let's check for the value of k. Even if whether it's inverse or not, it's important to have k. The second, we will substitute and try for another point. If it's correct, then it's an inverse equation, variation. Let's start with 1, 2. Here. Remember, to find for k, you have x, y. 1 times 2. So k is equal to 2. Here, let me teach you another technique for inverse. How do we check that it's an inverse variation? It happens when you multiply x and y and the answer is all the same. Example, 1 times 2, 2. 2 times 1, 2. 3 times 2/3, still 2. 4 times 1/2, 2. They are all the same. Therefore, this table expresses an inverse variation. What is our constant of variation? It's 2. Then let's write our equation of variation. We have y equals 2 over x. This is now our equation. Any questions? Feel free to raise your hand, okay, if you have questions. Now, I told you yesterday, right?
I don't need questions na, ma'am. I don't need
Okay.
questions na.
I told you yesterday, right? This is
Mama,
the easiest topic. Yes, there's a question.
This is second to the easiest chapter I've learned yet.
Okay, that's great to hear. Now let's go to the next one. The next one will be
Go.
here. The next one will be a graph. Now, how will we determine if it's a graph of an inverse variation? Here. You need to plot the points first. Name the points. 2, 6. Next, 3, 4. Next, 4, 3. The next one, I prefer very specific ones. 6, 2. Now, what will we do? Remember, we need to solve for k. And if k is the same, then it's an inverse variation. How do we do that? Multiply the 2 points. That's your k. 2 times 6. xy. Very good. So 2 times 6 is 12. Let's check if we have the same constant of variation for the rest. 3 times 4 is 12. 4 times 3 is 12. 6 times 2 is 12. They're all the same. Therefore, this is an inverse variation. The graph for an example of an inverse variation. with its constant of variation, 12. How do you write the equation? We have y equals 12 over x. This is our equation of variation. Now, let's go to the problem. Now, you can go with the general formula y equals k over x. Or another is k equals x times y. Now, the product rule for inverse variation can be solved when you multiply the first pair of x and y and equate it with the second pair of x and y. Why are they the same? Because the answer for this is the constant of variation. And the answer when you multiply this is also the constant of variation. So if you multiply the pair, then they will just be equal to each other. Like the one we had in our graph. 2 times 6 is the same as 3 times 4. The answer is the constant of variation. So how do we solve for the problem? We first stop my screen sharing.